Assalamualaikum and hi everyone. Today we will continue our lecture in Chapter 9, Carbonyl Compounds. For this part, we will discuss two subtopics, which is 9.1 Introduction to Carbonyl Compounds and 9.2 Nomenclature of Carbonyl Compounds. 9.1 Introduction to Carbonyl Compounds. At the end of the lesson, students should be able to give the general formula of aldehydes and ketones. Introduction. Aldehydes and ketones contain a carbonyl group which is carbon double bonded to oxygen. The carbon atom of this group has two remaining bonds that may be occupied by hydrogen, alkyl, or aryl substituents. If at least one of the substituents is hydrogen, the compound is an aldehyde. If neither is hydrogen, the compound is a ketone. This is a general structure for aldehydes. Aldehydes has carbonyl group which is carbon double bonded to oxygen and has one carbon chain at one side, either alkyl or aryl groups, and has one hydrogen atom at other side. This is a general structure for ketone. In this structure, it has carbonyl group which is carbon double bonded to oxygen and two group of alkyl or aryl group at the both side. 9.2 Nomenclature of Carbonyl Compounds. Learning outcomes. At the end of the lesson, students should be able to draw the structures and name the carbonyl compounds according to IUPAC nomenclature for aldehydes, carbon 1 until carbon 10, and ketones, carbon 3 until carbon 10s according to the IUPAC nomenclature, include common names. IUPAC nomenclature for aldehydes. The number of carbon atom in longest continuous chain that contains the CHO group provides the base name for aldehydes. The E ending of the corresponding alkane name is replaced by AL and substituents are specified in the usual way. Let's say we have 3 carbon atoms in alkane, the IUPAC name is propane, while 3 carbon atoms in aldehyde, the IUPAC name is propanol. When numbering the parent chain, the carbonyl group, which is carbon double bonded to oxygen, is always be carbon number 1 and therefore is not included in the name. Example 1. Example 1 has carbonyl group which is carbon double bonded to oxygen and has one hydrogen atom at one side. The longest continuous carbon contain carbon double bond O is 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, and 6 carbon. Carbon number 1 should be starting from carbon double bond O, carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5, and carbon number 6. IUPAC name given for the structure is hexanol. Example 2. The structure has carbonyl group which is carbon double bonded to oxygen and has one hydrogen atom at one side. The longest continuous carbon contain carbon double bond O is 1 carbon, 2 carbon, and 3 carbon. Carbon number 1 should be starting from carbon double bond O. Carbon number 1, carbon number 2, and carbon number 3. At carbon number 3, we have cyclohexyl as substituent group. IUPAC name given for the structure is 3-cyclohexyl propanol. Example 3. The structure contains carbonyl group which is carbon double bonded to oxygen and has one hydrogen atom at one side. The longest continuous carbon containing carbon double bond O is 1 carbon, 2 carbon, 3 carbon, 4 carbon, and 5 carbon. Carbon number 1 should be starting from carbon double bond O, carbon number 1, carbon number 2, carbon number 3, carbon number 4, and carbon number 5. At carbon number 2 of parent chain, it has ethyl group as substituent group. And at carbon number 4 of parent chain, it has methyl group. IUPAC name given for this structure is 2-ethyl-4-methyl pentanol. Example 4. In this structure, contain two groups of carbonyl group. Carbon double bonded to oxygen and has hydrogen atoms. In this structure, it has two carbon atoms. So the IUPAC name given is ethane diol. Di stands for two groups of carbon double bond O, which is carbonyl group. Example 5. In this structure, it has two functional groups, which is hydroxy group and carbonyl group. We choose carbonyl group as parent chain compared to hydroxy group due to priority. Carbonyl group has higher priority than hydroxy. So the longest continuous carbon that contain carbon double bond O is 1 carbon, 2 carbon, 3 carbon, and 4 carbon. Carbon number 1 should be starting from carbon double bond O. Carbon number 1, carbon number 2, carbon number 3, and carbon number 4. The hydroxy group attached to carbon number 3 of parent chain. So IUPAC name given is 3-hydroxybutanol. Example 6. This structure has two functional groups, which is carbon-carbon double bond and carbonyl group. We choose carbonyl group as parent chain compared to carbon-carbon double bond due to priority. Carbonyl group is higher priority than carbon-carbon double bond. So the longest continuous carbon has 1 carbon, 2 carbon, 3 carbon, 4, and 5 carbon. And carbon number 1 should be starting from carbon double bond O. Carbon number 1, carbon number 2, carbon number 3, carbon number 4, and carbon number 5. At carbon number 3, it has carbon-carbon double bond. So the IUPAC name given is 3-pentanol. Cyclic aldehydes. When the CHO functional group is attached to a ring, the suffix carbaldehyde is added, and the carbon attached to that group is carbon 1. According to the first structure given, we have CHO functional group directly attached to cyclohexane. So the IUPAC name given is cyclohexane carbaldehyde. According to the second example, we have CHO group directly attached to methyl cyclohexane. So the parent name for this structure is carbaldehyde according to CHO group. This carbon is carbon number 1, which is directly attached to carbon double bonded to oxygen. So carbon number 1 here, carbon number 2, and carbon number 3. So the name for this substituent group is 3-methyl. So the IUPAC name given is 3-methyl cyclohexane carbaldehyde. We look at the next example. According to this structure, we have CHO group directly attached to cyclic compound, which is cyclopentane. And we have two group of bromine attached to the cyclopentane. The carbon number 1 is starting from this carbon that directly attached to carbon double bond O. So carbon number 1 here, followed by carbon number 2 and carbon number 3. So at carbon number 3, we have two group of bromine. The IUPAC name given is 3,3-dibromocyclopentane carbaldehyde. Common name for aldehydes. A common name for an aldehyde is formed by taking the common parent name and adding the suffix aldehyde. Look at for this structure. This structure has carbon double bonded to oxygen and has two hydrogen atoms at the both sides. IUPAC name for this structure is methanol, and common name for this structure is formaldehyde. Next structure is ethanol. The structure has carbon double bonded to oxygen and has one hydrogen atom at one side, one carbon chain at the other side. Total number of carbon is 2 carbon. This structure is also known as acetaldehyde as common name. Next structure, benzene carbaldehyde for IUPAC name. This structure has carbonyl group, which is carbon double bonded to oxygen and has one hydrogen atom directly attached to benzene ring. So thus IUPAC name for this structure is benzene carbaldehyde, and also known as benzaldehyde as common name. IUPAC nomenclature for ketones. The E ending of alkene is replaced by ONE in the longest continuous chain containing the carbonyl group. Propane for alkene and propanone for ketone. When numbering the parent chain, the carbonyl group gets the lowest possible number. In the smaller ketones, propanone and butanone, the local number is not used because there is no alternative placement in the smaller ketones. The structure of propanone is propanone has 3 carbon atoms and carbon double bond O at the carbon number 2. This is a propanone structure. How about butanone? Butanone has 4 carbon atoms and double bond O at carbon number 2, either left or right side. These two structures, the local number is not used. Example 1. This structure is a ketone at carbon double bonded to oxygen. It has 2 carbon chain at the both sides. So the longest continuous carbon is 4 carbon. Carbon number 1 should be starting at nearest to carbon double bond O. So carbon number 1, carbon number 2, carbon number 3, and carbon number 4. The position of carbon double bonded to oxygen must be at the lowest number of carbon. The IUPAC name given is butanone. Example 2. This structure is ketone because we have carbon double bonded to oxygen and has 2 carbon chain at the both sides. The longest continuous carbon is 2 carbon, 3 carbon, 4, 5, and 6 carbon. So carbon number 1 should be start from nearest to carbon double bond O, which means starting from the left side. Carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5, and carbon number 6. And carbon double bond O must be at lowest number of carbon. So IUPAC name given is 3-hexanon. Example 3. This structure is ketone. Carbon double bonded to oxygen and has 2 carbon chain at the both sides. The longest continuous carbon is carbon number 1, 2, 3, 4, and 5. According to the structure, we have 2 substituent group, which is methyl group, attached to parent chain. So the IUPAC name is 2,4-dimethyl 3-pentanone. Example 4. According to this structure, it has 2 functional group, which is carbon-carbon double bond and carbonyl group. Carbonyl group is higher priority than carbon-carbon double bond, so that parent chain for this structure is carbonyl group, which is ketone. The longest continuous carbon for this structure is 1 carbon, 2, 3, 4, 5, 6 carbon, and carbon number 1 should be starting at the nearest of carbon double bond O. Carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5, and carbon number 6. At carbon number 4, we have double bond. The IUPAC name given is 4-hexene 2-one. The last example, example 5, we have carbonyl group, carbon double bond to oxygen, and has carbon chain at the both sides. So the structure is ketone. Carbon number 1 should be start from nearest to carbon double bond O. So carbon number 1, carbon number 2, carbon number 3. At carbon number 1, we have a benzene as a substituent group. Benzene as a substituent group we known as phenyl. So the IUPAC name for this structure is 1-phenyl 1-propanone. Cyclic ketones. With cyclic ketones, numbering always begin at the carbonyl carbon, but the 1 is usually omitted from the name. The ring is then numbered clockwise or counterclockwise, give the first substituent the lower number. Look at the first structure. In this structure, we have carbon double bond O at cyclopentane. So the IUPAC name is cyclopentanone. Look at the second structure. We have carbon double bond O at the cyclohexane. And also we have 2 substituent group, which is methyl and hydroxy group, attached to cyclohexane. Carbonyl group, we choose carbonyl group, which is ketone, as a parent chain compared to hydroxy due to priority. Carbonyl group is higher priority than hydroxy group. Carbon number 1 from carbon double bond O and carbon number 2 is nearest to substituent group because substituents group must be attached to the lowest number of carbon. So the IUPAC name given is 2-hydroxy 2-methyl cyclohexanone. Cycloalkanes which contain 2 ketones, both carbonyls need to be given allocation numbers. Also, Ne is not removed from the N, but the suffix dione is added. Look at the first structure. We have carbon double bond O at cyclohexane. So carbon number 1, from here, carbon number 2, 3, and 4. So the IUPAC name is 1,4-cyclohexane dione. Second structure given, we have 2 group of C double bond O at cyclopentane. So carbon number 1 should be starting from carbon double bond O and carbon number 2 for the next carbon. The IUPAC name of the structure is 1,2-cyclopentane dione. Common name for ketone. Most common name for ketones are formed by naming both alkyl groups on the carbonyl carbon. arranging them alphabetically and adding the word ketone. This structure we known as 2-butanone because we have 4 carbon atoms and we have carbon double bond O at carbon number 2. Carbon number 1 should be starting at nearest of carbon double bond O. Carbon number 1, carbon number 2, carbon number 3, and carbon number 4. So the impact name given is 2-butanone. At carbon double bond O, we have methyl group at the left side and ethyl group at the right side. So common name for this structure is ethyl methyl ketone. IUPAC nomenclature and common names for ketone compounds. This structure has 3 carbon and has carbon double bond O at carbon number 2. So IUPAC name for this structure is propanone. Common name for this structure is acetone. Second structure we have carbon double bond O bonded to carbon chain at the both side. So carbon number 1 is starting from carbon double bond O and carbon number 2 at the next carbon. At carbon number 1, we have benzene ring as a substituent group known as phenyl. So IUPAC name for this structure is 1-phenylethanone. The common name for this structure is acetophenone. This structure is a ketone because it has carbon double bond O and has 2 aryl group at the both side. So IUPAC name for this structure is diphenylmethanone and common name for this structure is benzophenone. We have finished our lecture 9.1 Introduction to Carbonyl Compounds and 9.2 Nomenclature of Carbonyl Compounds. Thank you for your attention.